In day 15, we are going to look at high quality graphs and review quadratics. Warm up. Find the coordinates of the vertex of the following function x squared plus 8x plus 16. Is it a maximum or minimum, and how do you know? So we've learned that one way to find the vertex, and there's several, is we can say, all right, the x value is going to be opposite b over 2a, which would be negative 8 over 2 times 1, which is negative 4. But the vertex, we need the coordinates, not just the x value, so we would need the y value. And so the y value, we're just going to plug in. I'll do it up here. We're going to plug in negative 4 into this function right here. So it'd be f of negative 4, which would be negative 4 squared plus 8 times negative 4 plus 12. All right, so if we do that, we will get the y value. When the x value is negative 4, let me type this in. Okay, now I get negative 4 as well. So f of negative 4 equals negative 4. And so our vertex would be at the coordinate 4, negative 4. Next question, is it a maximum or a minimum? So we take a look at the a value, and here the a value is a positive 1, which would mean it's a smiley face graph. And the vertex is where it changes direction, so that negative 4, 4 would be a minimum, because it would be the bottom of your smiley face graph. Okay, so today we're going to review and look at high quality graphs as well. So here's the review part. Can you change from vertex form to standard form? So this is called vertex form because you can easily see how the graph shifts. We know this goes left 8, and we know it goes down 7. And so the vertex would be negative 8, negative 7. Oh, I guess I did my shifts there. So left 8, down 7. The line of symmetry, the mirror line. And if you think about our graph, where is the mirror line? And the mirror line would be right here, the x value of the vertex. And if we know that this graph, which would start at 0, 0, but it shifts left 8, the mirror line will also shift left 8. So x would be negative 8. So whatever the x value of the vertex is, that will be the mirror line as well. So this graph will shift 8 to the left, which means that mirror line will also shift 8 to the left. Plot the vertex and sketch the quadratic. Be accurate with your vertex and direction, smile or frown, of the parabola. Okay, so we're going to shift this graph. So left 8, down 7. Oops. 6, 7, 8, 1, 2, 3, 4, 5, 6, 7. All right, so there it is. We just want to sketch the graph, and that's your line of symmetry right here. So here would be an example of our graph right here. It says be accurate with the vertex and direction. Is it a min or a max? And we can see that our vertex right here is a minimum. Let's convert it to standard form. All right, so standard form, we're going to multiply it out. We have 1/2 x plus 8 squared, and then minus 7. And when we're doing order of operations, when we're multiplying stuff out, the first thing we're going to do is our exponents. So we're going to multiply out x plus 8 times x plus 8, which will give us 8 squared, or x squared, 8x, 8x, and 64. So I'm going to write that over here. X squared plus 16x plus 64. But we're going to take half of that. So the next step is distribute the 1/2. So we have 1/2 x squared plus half of 16 is 8. So plus 8x. Half of 64 is 32. And then the last step is we have this minus 7 hanging out at the end. And we'll combine like terms. So we have 1/2 x squared plus 8x. And then 32 minus 7 will give us 25. And so that would be the same parabola, the same quadratic that was in vertex form, now in standard form. Okay, let's review factored form to standard form. Can we write the equation of this quadratic? So first we look at the zeros, or the x-intercepts, and there's 2 of them, -3 and +1. And we also will need a point to plug in to find the a value, so negative 1, 8. All right, so let's plug in and solve. So we have 8 equals our a value times x minus 3. Oh, and I didn't plug in the y-intercept. I'm sorry. I just plugged in negative 1, 8, which we could do, but I'll plug in the y-intercept. Okay, so our y-intercept is here at 0, 1, 2, 3, 4, 5, 6. 0, 6 is my y-intercept. Okay, so we're going to plug this in. So we have 6 equals 0 minus 3 and 0 plus 1. So we plug in zeros for the x's that were in factored form. And we'll multiply this out. 6 equals a times, we have negative 3 times 1, which is negative 3. We'll divide each side by negative 3. And so here our a value is negative 2. So the equation in factored form will be y equals negative 2 times x minus 3 times x plus 1. And see why the a value is negative 2. It's upside down, like a frowny face, because the a value is negative, and it's skinnier than the original because the value of a is 2. All right, E, convert your equation to standard form. So when we multiply this out, we're going to pick any two to multiply together first. So I'll just distribute that, and we'll get negative 2x plus 6. And we're going to take that and multiply it by our last term, which is the x plus 1. So we'll get negative 2x squared plus 6x minus 2x plus 6. And we'll combine like terms, and we'll get negative 2x squared plus 4x plus 6. So here's standard form of our quadratic equation. Okay. And then last review, and then we get to the new stuff. Standard form to factored form. So this isn't standard form, there's no parentheses, we want to factor this. First step is, can we divide everything by 2? We can't without getting a fraction or decimal, so we're going to use box and circle. So we have our 2x squared, our negative 5x, our negative 12. We want to know what multiplies to our first and our last number, so negative 24x squared, that adds to negative 5x. And that would be a negative 8x and a 3x. So we'll put our x's on the outside. We need the 2, and it will be easier on the side. 2x times negative 4 is negative 8. X plus 3 is 3x. All right, so here are the factors. 2x plus 3, x minus 4. The zeros are the opposite of the factors, so one of them is pretty easy. It's just 4. The other one, if you don't know, make an equation. 2x plus 3, set that equal to 0, and we'll solve. We'll subtract 3 from each side. We get 2x equals negative 3, and divide each side by 2. And so x would be negative 3 halves, or negative 1.5. So those are the zeros. All right, so that's all review, but today we're going to look at high-quality graphs, finding out a bunch of coordinates so we can graph them and see what this graph looks like. Okay, so here it is. A ball is hit into the air with an upward initial velocity of 48 feet per second. Its height in feet after 2 seconds is given by this right here. Okay, what is the starting height of the ball? And that would be at time 0. So really you're finding h of 0 and time of 0. That's negative 16 times 0 squared plus 48 times 0 plus 4. And if you notice, anything times 0 is 0, so this would cancel, and your starting height at time 0 would be 4. What height would the ball be when 2 seconds has passed? All right, so now it's asking you to find after 2 seconds, so h of 2 equals negative 16 times 2 squared plus 48 times 2 plus 4. All right, so let's plug that in. Negative 16 times 2 squared plus 48 times 2 plus 4. Oops, I put plus 1. Okay, so when I type that in, I get 36. So the height at 2 seconds would be 36 feet. In how many seconds will the ball reach its maximum height? And if we draw a picture of this, okay, so it starts at a height of 4, it's going to go up and down. We're looking for the vertex. So this is the vertex. And the vertex, we have x equals opposite b over 2a to find the x value. The opposite b of b is negative 48 over 2 times negative 16. So we'll divide that out. Negative 48 divided by negative 32. And it would be 1.5 seconds. It will reach its maximum height. What is the maximum height? So now we're going to plug in h of 1.5. So negative 16 times 1.5 squared plus 48 times 1.5 plus 4. 16.5 squared plus 48 times 1.5 plus 4. All right, it would be 40. So the height at 1.5 seconds is 40 feet. When will it reach the ground? That's the zeros. I'm just going to use quadratic equation. I mean, we could factor it out and solve it. All right, so x equals opposite b, negative 48, plus or minus the square root of b squared, 48 squared, minus 4 ac, a is 4, c is negative 16, all over 2a, and a was negative 16. All right, so we're going to figure out these parts right here, the discriminant, the bottom, and we'll get negative 48 plus or minus the square root of, I'll type it in, so it should be 48 squared, not 42 squared. 48 squared minus 4 times negative 16, 2560 all over negative 32, and we solve that, negative 48 plus the square root of that divided by negative 32. All right, so one of our answers is negative 0.08, but what's the other one? Negative 48 minus the square root of 2560, hit enter, divide by negative 32, and we get 3.08. All right, so when does the ball reach the ground? 3.08. All right, to graph this, we have two variables. One is time, which is the independent variable, and one is height. So let's take a look at maximum time to hit the, when does the ball reach? We have to go out at least 3 seconds. What's the maximum height of the ball? That was 40 feet. Okay, so I'm just going to go 10, 20, 30. This is 40. This is in feet. And I'm just going to go by seconds. 1, 2, 3, 4. This is 4 seconds. Okay, let's graph it. So we know that at time 0, the height was 4 feet. So that would be like right here. Okay, what else do we know? We know the vertex was at 1.540. All right, so here's 1.540. Okay. What else do we know? We know after 2 seconds is at 36. All right, so 2 seconds, 36. And we know hits the ground at 3.08. So here's 3 seconds, here's like 3.08. So here is our quadratic. Oops, that's not great. Okay, so that's your high quality graph when you're graphing all the important pieces of information. So practice reviewing today and also putting everything together and drawing your high quality graph.